What's up guys, welcome back to a new video, and in this session we'll be looking at exercises on how to solve determinants of a 2x2, a 3x3 and even for those brave souls a 4x4 matrix. I will be going over these exercises step by step, explaining everything I do along the way. As always, these exercises start out very basic, in this case with the 2x2 matrices, but get progressively more difficult towards the end, and in this case ending with calculating the determinant of a full-flexed 4x4 matrix. So feel free to skip around according to your own level and interest. The timestamps of each exercise will be found in the comment sections below or the description. As you can see, I've written down the general formula to calculate the determinant of a general matrix A. As is oftentimes the case with mathematics, instead of breaking our head over these abstract, complex and general formulas, I think it's much better to get an understanding by doing the exercises. And this is why in this video I will be only focusing on the exercises part. With that out of the way, let's go to the first exercise. The first exercise is to calculate the determinant of a 2x2 matrix, and the matrix is given here. For a 2x2 determinant, what we need to do is quite simple. We need to multiply these numbers on the diagonal, and then we need to subtract the product of the numbers on the off diagonal. So how does this work in practice? So we multiply 1 times 4, and we subtract the numbers on the diagonal, so 2 times 3. In this case, this becomes 4 minus 6, which is of course minus 2. And we already have our initial result. So the determinant of the matrix 1, 2, 3, 4 is simply minus 2. Let's go to the next exercise. The next one is taking the determinant of 2, minus 5, 1/2 and minus 3. Again here, what we do is we multiply the numbers on the diagonal and we subtract the product of the numbers on the off diagonal. In this case, it becomes 2 times minus 3 minus 1/2 times minus 5. And in this case, we really have to be careful with this minus sign in front of the minus sign, and we should not forget it because then our result will be wrong. This simply becomes minus 6 minus, and let me do this in 2 steps. So we get minus 5 divided by 2, and this becomes minus 6 plus, because we have 2 minus signs here, which become a plus sign, 5 divided by 2, which is minus 6 plus 2.5 is simply minus 3.5. And we again have our result quite easily. Let's now go to the last exercise of a 2x2 matrix, in which we have to calculate the determinant of the following matrix: 1, 2, 3, 6. Again, we multiply these numbers and we subtract these numbers. So we get 1 times 6 minus 2 times 3. And in this case, this simply is 6 minus 6, and well, it's basically 0. At this point, I want to show you guys something, because this tip or this trick can save you a lot of time while calculating determinants. And this trick is the following. We got the determinant is equal to 0. However, you could already seen that right from the beginning. And why is this? Because this row of the matrix, 3, 6, is exactly 3 times the first row. So 1 times 3 gives 3, and 2 times 3 gives 6. So this entire row, this entire first row gets multiplied by 3 to get the second row. If this is the case, then the determinant will always be 0. So keep in mind that before going into the calculation to get the determinant, look for rows or columns that are multitudes of each other. the same holds for columns, by the way. You see that this column is simply 2 times the first column, because 1 times 2 is 2, and 3 times 2 is 6. So it also holds for columns. So this is something that you really want to look out for instead of first going into the calculation right away. Let's get to our first exercise where we have to calculate a 3 times 3 determinant, which is a bit more involved, but we'll be able to do it step by step. The matrix is this 1, 0, 2, minus 1, 1, 3, 4, 2, minus 3. How do we calculate this one? First, we start by taking this first element here and we just copy it and we multiply it with the determinant that is formed by ignoring the row on which this one is situated and the column of which this one is situated. And the result is these 4 numbers here, and we take the determinant of these 4 numbers. So this looks like follows: 1, 3, 2, minus 3, and the determinant of this 2 times 2 matrix, which is formed by these 4 numbers. Then we subtract this 0, and the 0 multiplied again by the determinant that we get when we ignore the row in which this 0 is situated and the column. And the numbers that we are left with are these 4 numbers. And these 4 numbers we use as the determinant that we need to calculate and multiply with this 0. This looks as follows. So we get minus 1, 3, 4, and minus 3. Minus 1, 3, 4, minus 3. And again, I draw this in red because I want to make clear that you have to put this minus sign in front of this term. Then the third term and the last term is this 2, and it's again with a plus sign. So we get plus 2 times, again, the determinant that is formed by ignoring the first row and the third column. So the row and column of which this 2 is a part of. And we get that we have these 4 numbers, which will be our numbers that we take the determinant of, that we multiply with this 2. So this then becomes the determinant of minus 1, 1, 4, and 2. Again, these numbers, minus 1, 1, 4, and 2. And basically now the most difficult part is over. How does this now look when we calculate it? So we get 1 times, and again now we just calculate a 2 times 2 determinant, which we did already 3 times in the previous exercises. So we multiply these 2 numbers and we subtract the product of these 2 numbers. So we get 1 times minus 3 and we subtract 2 times 3. And that's already our first term. Then negative, so minus, which is this minus here. 0 times, well, and then it doesn't matter because we just have 0. So whatever this determinant is, it doesn't matter because we multiply it by 0, so it just drops out. Plus 2, which is this third term. The determinant of this 2 by 2 matrix is again the multiplication of these 2 numbers minus the product of these 2 numbers. So we get minus 1 times 2 minus 4 times 1. And there we have it already. So we have 1 times minus 3 minus 6 is minus 9, plus 2 times minus 2 minus 4 is minus 6. And then our result becomes minus 9 minus 12, which is of course minus 21. And this is our result for the initial 3 by 3 matrix. This is how we calculate a 3 by 3 determinant. This went quite well, so let's go to the next exercise, which is again a 3 by 3 determinant of minus 2, 3, 5, 1, 6, 1 half, 5, 1, 0. And again, the first step is the most important one and the one where students make the most errors. So again, we take this first element, minus 2, and we multiply it with the determinant of the numbers that are left when we ignore the first row and the first column. So the row and column of which this minus 2 is a part of. And in this case, it's 6, 1/2, 1, 0. So we multiply this by 6, 1/2, 1, 0. And this is just a 2 times 2 determinant, so we can easily calculate it. Now comes the step that most students get wrong. You get this second number, but you put a minus sign in front of it before you multiply it with the determinant that you get from the numbers that are left when we cancel the first row and the second column, which in this case is 1, 5, and 1/2, 0. So this becomes minus 3, and this minus sign is very important. Minus 3 times the determinant of 1, 1/2, 5, 0. And again, 1, 1/2, 5, 0 comes from ignoring the column and row of which this 3 is a part of. Then we take this third element, we add 5 times the determinant that comes from ignoring the column and the row of which this 5 is a part of, and we look at the numbers that remain. So it's 1, 6, 5, 1. So we get 5 times the determinant of 1, 6, 5, 1. And now we calculate these 2 times 2 determinants and just never forget these numbers in front of it. This becomes minus 2, not to be forgotten, and then this 2 by 2 determinant. So we get the multiplication of these two numbers minus the product of these two numbers, which becomes 6 times 0 minus 1 times 1/2. And we already calculated the first determinant, the first term in this 3 by 3 determinant. Minus 3, this term, times the determinant, which is 1 times 0 minus 5 times 1/2. So we get 1 times 0 minus 5 times 1/2. And then the last term is this plus 5 times, and then this last 2 by 2 determinant, which simply becomes the multiplication of these two numbers minus the product of these two numbers, which is 1 times 1 minus 5 times 6. And we calculate these simple algebraic equations, which becomes minus 2 times 0 minus 1/2 minus 3 times 0 minus 5 divided by 2, which is this term, plus 5 times 1 minus 30, because we have 1 minus 6 times 5. We can still rewrite this as minus 2 times minus 1/2 minus 3 times minus 5 over 2, which is this term, plus 5 times minus 29. And this simply becomes 1, because minus 2 times minus 1/2 is plus 1, plus 15 divided by 2, because minus 3 times minus 5 over 2 is 15 divided by 2, minus 145. And this then simply becomes, after a bit of calculation, minus 136.5. And this is our final result for our initial 3 by 3 determinant. Let's go to the next 3 by 3 determinant. But before calculating, I want you to take a minute and just look at it. So we have minus 5, 6, 8, 3 minus 2, 6, 10, minus 12, and 16. Again, we could go right in and start calculating this by taking this number, doing it times this determinant, this number, and the other determinant. Now we could go straight in and start calculating. However, I want you to remember the trick that I told you at the start of this video, where we calculated a 2x2 determinant of which one row was the multitude of the other row. And we know that if this is the case, if a row or a column is simply a number times another row or column, that the determinant will always be 0. And for this matrix, this determinant, it's also the case, because let's look at this first row and this third row and see how they are related. We see that we get from -5 to 10, from 6 to -12, and from 8 to 16. We see that this row is just times -2 of the first row. So the third row is a number times the first row. And this means that this determinant will always be 0. So this saved us a lot of calculation just by looking at the determinant and seeing whether rows or columns are a multitude of others. So this saved us a lot of time, and we see that the determinant is 0. To end this video, let's look at the determinant of a full-flexed 4x4 matrix. So this is the 4x4 determinant that we will try to solve. And in order to solve this, you just have to follow the same steps as before, only now it gets more extended. The calculations become more extended, but the same basic principles apply. So let's get into it. First, you take this 2 and you write it 2 times, and you multiply it with the 3x3 determinant when you ignore the row and the column of which this 2 is a part of. In this case, what remains is this 3x3 determinant. So we multiply this 2 by the 3x3 determinant, 2, 0, 4, 1, -3, 2, and 0, 2, 1. And again, this is simply these these 9 numbers. The next step is to take this -1, so the number on the right of the 2 that we used, and we put a minus sign in front of it, which is very important, which is why I draw it in red. And again, we multiply this number by the determinant that remains if we ignore the row and the column of which this -1 is a part. And what remains then is these 3 numbers and these 6 numbers. So we multiply this -1 with the determinant made of these 9 numbers. And in this case, we get the determinant of 1/2, 0, 4, -1, -3, 2, -3, 2, 1. And then we can get to the next number, which is this 2 over here. And here again, we get a +2 times the determinant that remains if we ignore the column and the row of which this 2 is a part of. Now we get that these 6 numbers and these 3 numbers will make up our determinant that we have to multiply by this 2. This means that we get the determinant of 1/2, 2, 4, -1, 1, 2, -3, 0, 1. And we can now get to the last number, which we again put a minus sign in front, which is very important. And it's this 3. So we get 3 times. And again, we multiply this 3 with the determinant that we get from the numbers when we ignore the row and column of which this 3 is a part of. And in this case, we get these 9 numbers, which becomes 1/2, 2, 0, -1, 1, -3, -3, 0, 2. And now the unique part of solving a 4x4 determinant is already over, because at this point we reduced this 4x4 determinant to 4 3x3 determinants, and we know how to solve 3x3 determinants. So basically the most difficult and, well, daunting part is already over. So let me scroll down, because at this point we have to calculate each of these 4 determinants separately. And again, of course, not forget to multiply it with these numbers in front of it. Let's just do this step by step and start with the first one. So we have 2 multiplied by the determinant of this 3 times 3 matrix. And again, the determinant of this 3 times 3 matrix can be calculated in a similar fashion as before. So we get this 2 times, and we calculate the determinant that remains if we ignore the column and the row of which this 2 is a part of. And what remains are these 4 numbers. So we get that this becomes the 2 times the determinant of -3, 2, 2, 1. And there we have it already. Then we have this 0, which gets a minus sign in front of it. So -0 times the determinant that remains if we ignore this row and this column, and we remain with the numbers on the sides of it. So we get the determinant of 1, 2, 0, 1. Then we get this 4, so we add 4 times, again, the determinant, when we ignore the column and the row of which this 4 is a part of, and we get these 4 numbers. So we get 4 times the determinant of 1, -3, 0, 2. And we already have our first term. The same can be done for the second term, which is this term. And here we have to remember that we have this -1 becomes +1. So we have +1 times, and then of course the determinant of this 3 times 3 matrix, which we can calculate in the same fashion. We take this 1/2 and we multiply it with the determinant that remains if we ignore the column and the row of which this 1/2 is a part of. And what remains are these 4 numbers. So we get 1/2 times the determinant of -3, 2, 2, and 1. Again, we get this 0, we put a minus sign in front of it, and we multiply it by the determinant. By now you will know how it goes. Remove the row and column of which this 0 is a part of, and we get these 4 numbers which will make up our determinant. So we get 0 times the determinant of -1, 2, -3, and 1. Then we add this last number, again a 4, so 4 times the determinant when we remove this and this column and row, and we are left with these 4 numbers to take the determinant of. So it's -1, -3, -3, 2. And again, now we have already the second term. The third term will be a +2 multiplied by this 3 times 3 determinant, and by now we know the drill. We take this first number, 1/2, and we multiply it with the determinant that remains if we cancel or ignore this column and this row of which this 1/2 is a part of, which are simply these 4 numbers. So we get 1/2 times 1, 2, 0, 1. Then we take the next number, which is 2. So we get -2. This minus sign is very important not to forget. The determinant of these 4 numbers. So we get the determinant of -1, 2, -3, 1. Plus this last number, 4 times the determinant when we ignore this column and this row. So we get the determinant of -1, 1, -3, 0. And we have our third term. Now to get to the last term, we have this -3, which is important to remember that we have to take with us the minus sign. So we have -3 times the determinant of this 3 times 3 matrix, which is 1/2 times the determinant that remains if we remove this column and this row, which is these 4 numbers. So we get the determinant of 1, minus 3, 0, 2. This next number, a 2, with a minus sign in front of it, times the determinant of these 4 numbers. So this becomes minus 1, minus 3, and 2. And then the last number is this 0, and again we ignore this row and this column, and we multiply it with the determinant formed by these 4 numbers. So we get plus 0 times the determinant of minus 1, 1, minus 3, and 0. And at this point, we are now finished with calculating 3 times 3 determinants. So what we did is we reduced these 4 3 times 3 determinants to effectively 12 2 times 2 determinants. And again, these 4 3 times 3 determinants came from 1 4 times 4 determinant right here. So in a sense, we're reducing the problem into more problems, but these problems are problems that we can solve. And this way we solve the thing that we couldn't solve in the beginning. And now we are left with 2 times 2 determinants, which we know how to solve, of course. So we have 2 times this first term, which becomes 2 times then the determinant of this 2 times 2 matrix becomes the multiplication of these 2 numbers minus the product of these 2 numbers. So we get minus 3 times 1 is minus 3, minus 2 times 2 is 4. And we already have this first term down. Now this second term is 0 times this determinant. And 0 times any determinant is just 0. So we don't have to calculate anything here, we just add 0. Then for this last term, we have 4 times this 2 times 2 determinant. So plus 4 times, again, the product of these 2 numbers minus the product of these 2 numbers, which becomes the product of these first 2 numbers on the diagonal becomes 2 minus 0 times minus 3 is 0, so it just becomes 0. And we already have our first term. Let's go to the next term. So we have this plus 1 in front of it. So we have plus 1 times. Then we get, of course, our 3 determinants that we have to calculate. We don't forget this 1/2 in front of it. So we have 1/2 times minus 3 times 1 is minus 3. And then we multiply this with minus 2 times 2 is minus 4. And we already have our first term. Then again, we see that we have minus 0 times a determinant, which is again very conveniently 0, plus 4 times this number times this number is minus 2. So 4 times minus 2 minus, and now this gets a bit tricky. So minus 3 times minus 3 is plus 9, but we have to minus this number, so we have minus 9. And we already have our second term. Let's go to the next one. So we have this 2 in front of it, so plus 2 times, then the sum of these 2 times 2 determinants. The first one, we don't forget this 1/2, so 1/2 times the determinant of this one, which is 1 times 1, which is 1, minus 0 times 2, which is 0, so minus 0. Then we'll get this term, so minus 2 times minus 1 times 1 is minus 1, minus minus 3 times 2 is minus 6, so we have to minus 6, and I will just write it out fully here, not to get any confusion, and calculate it in the next step. Then the last term is this plus 4, so plus 4 times the determinant is minus 1 times 0 is 0. So we have 0 minus 3 times 1 is minus 3. So minus 3. And we have our third term. And we go to the last one, which is minus 3 times the sum of these 2 times 2 determinants. So we have minus 3 times, again, don't forget this 1/2 in front of it, 1/2 times, the determinant will be 1 times 2, which is 2, minus 0 times minus 3 is 0, so minus 0. Then we have minus 2 times, the determinant of this is minus 1 times 2 is minus 1, minus the product of these two numbers, which is minus 3 times minus 3 is plus 9. So we have minus plus 9 is minus 9. And then for our last term, we are in luck because we just have plus 0 times this determinant, which is just 0. So we are finished here. At this point, we don't have any determinants left, only some algebraic equations. So we have reduced the 4 times 4 determinant to 4 3 times 3 determinants, which we reduce to 12 2 times 2 determinants, which we now have solved. And well, we are left with this simple sum, which we are going to calculate right now. So we have 2 times minus 7 is minus 14, plus 0 is 0, plus 4 times 2, which is 8, so plus 8. Plus 1 times, and then we're arrived at this term, 1/2 times minus 3 minus 4 is minus 7, so we get minus 7 over 2. Plus 0, which we can just drop. And then here we have 4 times minus 2 minus 9 is minus 11. So 4 times minus 11 is minus 44. Then we get to this term. So plus 2 times 1/2 times 1 is 1/2. Minus 2 times, and now this becomes this tricky part. So we have minus 1 minus minus 6. So it's plus 6. So minus 1 plus 6 is plus 5. And then we have to multiply it with this minus 2. So we get minus 2 times plus 5 is minus 10. And then we get 4. So plus 4 times minus minus 3 is plus 3. 4 times plus 3 is 12. So we can just put a 12 here. And then the last term, we have minus 3. So this becomes minus. I was too fast here. So minus 3 times 1/2 times 2 is simply 1. Minus 2 times minus 2 minus 9 is minus 11. And minus 2 times minus 11 is plus 22. And this term just, well, we add 0 and it remains 0. Now we're almost there. We just have to calculate these few brackets here. So we get 2 times minus 14 plus 8 is minus 6. So we get 2 times minus 6 plus 1 times, so this 1 can drop. We have minus 7 over 2 minus 44, which is minus 47.5, because 7 over 2 is minus 3.5. Then plus 2 times 1/2 minus 10 plus 12. Minus 10 plus 12 is 2. 2 plus 1/2 is 2.5. And then this last term, minus 3 times 23. And now we're really almost there. So we get minus 12 minus 47.5 plus 5 minus 69 for a grand total of minus 145.5. 23.5. And this is our final result. And I checked it, we didn't make any mistakes. So this number is the result of this 4x4 matrix. This brings us to the end of this video, and I really hope that you learned something. As always, if you have any questions or remarks, or if you have any suggestion for future topics, leave a comment below. I can still read all of them and most probably reply to all of them. As always, if you learned something, please give it a like, because then people that also struggle with these topics are more likely to find these videos. And if you want to get notified by future videos, just subscribe to the channel. And with that out of the way, I see you guys next time. Bye.